The raw materials are the lifeblood of the factory. Every pallet is precisely weighed before being introduced to the mixing process.
Check the blend consistency on drum 4.
Reading stable. Adjusting slip feed rate now.
Here in the filtration bay, technicians monitor the slurry as it passes through the layered mesh filters.
The shaping studio combines traditional craft with cutting-edge automation, ensuring every seam is perfected.
The viscosity is stable at 450 centipoise. Good, the pigment dispersion looks consistent across all batches.
The heart of the operation, a spray glaze tunnel, where synchronized multi-nozzle sprayers precisely coat each piece.
Here we see the intricate blend of modern automation and traditional artisan skill, ensuring every detail is perfect.
The transcription is not needed for the process.
Keep an eye on this spike here.
I see it. It appears to be stabilizing.
Here in the primary cooling zone, temperatures rapidly descend as the robotic carts precisely navigate the cryotunnel.
Increasing the pressure to 40. The glaze is holding. Looks perfect now.
Checkpoint 4 here.
Reading at 98%, well within tolerance.
The initial drop simulation data looks promising, well within tolerance.
What about the thermal shock metrics? We saw a spike earlier.
It stabilized after the 3rd cycle.
We use the micro tools to apply the slip precisely before the final polish. It fills every imperfection.
The delta E on this batch is acceptable.
Confirmed. Send it through the sorter. Look at the resonance peak here on the blue curve.
I see it. Let's isolate the frequency response around the impact point.
This is the heart of the operation, where man and machine collaborate to meet the demands of global distribution.
The precision of the automated arms ensures each ceramic is perfectly nestled into its protective foam.
As packages race through the tunnel, synchronized lasers ensure every barcode is verified before the robotic pushers sort them for shipping.
The reflectivity on the bezel looks perfect at this angle.
DataStream confirms optimal light exposure across the gradient.
The viscosity seems promising, much smoother than the last iteration.
I agree. The cobalt is fully incorporated now.
The scan shows consistent density across the z-axis.
But we have a spike localized here at the 5th layer.
Let's rerun the thermal sequence.
Pressure on the 3rd pass needs adjustment.
Let's increase the flow rate by 5% and rerun the simulation.
The flow rate on line 4 is steady. Good. Let's maintain this pace until the next rotation.
That's a clean finish. The automated sequence is working perfectly on this batch.
Understood. I'm logging the parameters now.
The robotic arms apply a precise, even coat of glaze, illuminated by the high-intensity LEDs, ensuring a flawless finish every time.
We have a slight fluctuation here in zone 3.
I see it. Adjusting the controls now.
The crystallization is accelerating right on schedule.
And the thermal gradient remains stable across the tile.
We have to adjust the pressure very carefully, otherwise the glaze will crack.
The spike at 40 hertz significant. We're seeing resonance right there.
Yes, but the dampening effect seems stable across the prototypes.
We have a critical status change on the Pacific route. Reroute batch 7 immediately to avoid the weather delay.
Confirm ETA.
The flow rate is within tolerance, no splashing.
Confirmed. Glaze integrity is holding up well under the weight test.
Excellent. Let's finalize the report.
Inside the premium curing chamber, robotic arms ensure an even exposure to the UV light, critical for the stability of these rare glazes.
The glaze consistency is superb, but perhaps slightly heavy near the base.
Agreed. Let's compare the texture with the matte finish on this one.
The team really outdid themselves this cycle. The colors are magnificent.
They certainly did. This is a huge success for the department.